Welcome back. In the previous video, I introduced the propositions, the idea of propositions, and how we use them with logic and proofs. Here in this second paragraph, we're going to look at defining the propositions. What are propositions and what are examples? What are the rules that a proposition has to follow? And we also will be looking at the value of a proposition. Is the value true or false? Do we have a proposition which provides us a true value or a false value? It's very important for the next part in this paragraph. Now, what is a proposition? A proposition is basically a declarative sentence where we declare something to be true or false. We declare a certain fact, a fact that is a statement. And let's have a look at some examples of propositions. We have here a table with some propositions. And what we have to do is to find out if this proposition is true or false. I've chosen here 4 propositions. I say Prague is the capital of the Czech Republic. The second one, Texas is a country in South America. Father Damien died in Molokai. And 5 plus 7 times 3 is 36. Now you can have a look, you can stop the presentation here and try to find out if these elements are true or false. Which propositions are true and which propositions are false. When you continue with the video, you will see that we will have some answers for it. First of all, Prague is the capital of the Czech Republic. Well, if you know this, if you know Czech Republic, you will know that the capital of the Czech Republic is Prague and that this proposition is true. Another element, Texas is a country in South America. Well, we always think about Americans not knowing Europe, but perhaps we don't know America. When we look at the United States and we find what states they have, we will find that Texas is not a country in South America. When you look at South America and the map of South America, you will see there is no country called Texas. So this proposition is false. This may be a little bit more difficult. Father Damien died in Molokai. Now you may ask, who the hell is Father Damien? Where is Molokai? Well, Molokai is one of the islands in Hawaii. It's one of the islands surrounding Hawaii. You have the Oahu, where you have Honolulu, you have Big Island, you have different islands around, and Molokai is one island where they had a colony for people who were suffering from Hansen's disease. Hansen's disease is in fact more nice name for lepra. Basically, who is Father Damien? Father Damien, if you look on the internet, you will see that Father Damien was a Belgian priest who went to Molokai to help the people on Molokai to deal with their illness. And basically, he died in Molokai. So this is in fact something that we can verify when we Google it. There are a lot of things like that. We may have propositions, and it's sometimes difficult to find the truth. You have to look onto the internet, who is Father Damien, where is Molokai, and link Father Damien to Molokai. I've been there, I've seen his grave, and in fact is very much loved by the people because of his sacrifice. He died there helping the people to deal with their illness. Another proposition is 5 plus 7 times 3 is 36. Now this is based on the rules of mathematics. So when I have 5 plus 7 times 3, well, 5 plus 7 is 12 times 3 is 36. But this is not true. This is a false proposition because when we use the rules of mathematics, we know that we first have to do the multiplications, then the divisions, then the additions, and then the subtractions. So basically, we first have to multiply 7 times 3, which is 21, plus 5 gives us 26. So this proposition is in fact false. Now we also have to be able to distinguish between propositions and the sentences that relate to it, or different sentences that we have to evaluate. Here are some sentences, and we have to know, is this a proposition, yes or no? So first of all, where are you from? Where are you from? Is that a proposition? Is that a statement? Basically, it's not a statement, so it's not a proposition. It is a question. It would be a proposition saying, you are from Prague. That would be a proposition. But here we are asking a question, and we're asking for an answer. Another element that we have is go to the left. Go to the left is not a statement, it is an order. You tell somebody to go to the left. It's not a proposition. And we have two propositions or sentences here. 5x plus 3 equals 7, and ax squared plus bx plus c is larger or equal than 0. Now, these are in fact expressions where x is a variable. We cannot say that it's true or false. All depends on the value of x, and in the second expression, on the values of a, b, and c. So these are clearly not examples of propositions, and we cannot treat them as such. So when we see sentences like this, which are not really a declaration, we can automatically say that they are no propositions. But let's have a look at 5x plus 3 equals 7. The expression is not a proposition because we don't know if we cannot say if it's true or false. In this expression, we have the letter x, which is a variable, and the letter x can basically take any value. We can define the value x can be any real number, can be an integer. We can define that if we have certain limitations. But basically, x is a variable. And we can transform this into a proposition. For example, we can say x is equal to 1. So in this moment, we have 5 times 1 plus 3 is 7. And we have a proposition because this is a clear declaration of an equality. Now, is this equal to 7? So 5 times 1 is 5 plus 3 is 8. So in that case, when we say x is equal to 1, the proposition is false. On the other hand, when we allocate x to be equal to 4/5, then this expression becomes true, because 4 times 5 divided by 5 plus 3 is 7. Another thing we can do is in fact look at propositional variables. And propositional variables are statement variables, and they are typically represented by letters like P, Q, R, and S. There may be others depending on how many propositions we have. We can also say P index 1 or P index I to have more propositions. All depends on the quantity of the propositions. So what will we do with that? For example, we say the proposition or different proposition, but let's take the example that we had before. Prague is the capital of the Czech Republic, and we say this proposition I represent by the letter P. I can also represent it by Q, R, or S, or another letter, but let's just say this is in fact the proposition P, which is in fact the same as Prague is the capital of the Czech Republic. So basically, when we will be working with propositions, we will be in most cases replacing them by those letters to make the reasoning easier. And we don't have to rewrite those long propositions all the time. But there's something more about propositions. We have to look at the truth value. We looked at the truth value at the beginning of this video. We looked at the statement, for example, that Texas was a country in South America. We said it was false. Prague is the capital of Czech Republic. It is true. So in fact, the truth value of a proposition relates to being true or being false. And typically true is indicated by the capital letter T and false by the capital letter F. And when you remember some applications and formulas in Excel, you will see that in some formulas that you have to add true or false to the formula. And true or false, in that case, relate to a certain statement. When it's true, I will do this. When it's false, I will do something different. Now, when we have a proposition, it is either true or false. It cannot be between the two. It cannot be both. It's either true or it is false. When we look at the logic, the area of the logic where we deal with propositions, we call it the propositional calculus or propositional logic. This part of mathematics and logic was already developed by Aristotle in Greece about 2,300 years ago. So these elements are still used today, and they're at the basis of propositional calculus and logic. We will deal with that in the next session. Now, the next session will be about the compound propositions. We will be using propositions, we will be combining them with operators, and we will look at the truth values of those combined propositions. And that's a very important part because those truth tables that we are going to create will be used later to identify what is happening with the logic, what are the truth values of the compound propositions. We finished another presentation. You're doing a great job. We're still at the beginning of the course, and I hope you have no problems here, that you can follow everything. And of course, I'm looking forward to seeing you in the next presentation. Thank you, and bye-bye.